In the previous class, we saw how to apply divide and conquer approach to deduce DIFFT algorithm and how to draw the butterfly structure of DIFFT algorithm. In today's class, let us try to apply DIFFT algorithm in order to find out DFT. So, both 4-point as well as 8-point DFTs. So, the first problem is to find out 4-point DFT of the sequence x of n, which is equal to 1, 2, 3, 4 using DIFFT algorithm. Okay. So, one thing which we need to keep in mind with respect to DIFFT algorithm is the input of DIFFT algorithm will be in normal order, whereas the output of DIFFT algorithm will be in bit reversed order. That is the most important thing which we need to keep in mind. Whenever we need to find out DFT using DITFFT algorithm, the input was in bit reversed order and the output was in normal order. So, this is vice versa of that. Okay. So, keep that difference in mind whenever you try to solve the problems related to DFT using DITFFT algorithm or by using DIFFT algorithm. Okay. So, since the value of n is equal to 4, so we know the standard equation for n is equal to 2 power b. So, if I express 4 in terms of 2 power b, I can write it as 2 square. Therefore, the value of v is nothing but equal to 2, which tells the number of stages that should involve in this problem is 2. So, this is our first stage. So, this is stage 1 and this is stage 2. Okay. So, the input is in normal order and the output is in bit reversed order. So, this is the given sequence. This is x of 0, this is x of 1, this is x of 2 and finally this is x of 3. So, let me tabulate the data here. So, x of 0 is 1, x of 1 is 2, x of 2 is 3, x of 3 is 4. Okay. So, I need to find out the output of the first stage. So, we are ready with the input. Let us try to find out the output of first stage. So, the signal coming from this branch is 1. The signal coming from this branch is 3. What I need to do at this point? I need to add the data. So, if I add 3 and 1, we get it as 4. Similarly, coming to this point, here the signal coming is 2 and from this branch the signal which we are getting is 4. 2 plus 4 is 6. So, coming to this point, okay. So, from this branch we are getting 1 and from this branch 3 is multiplied with minus 1, it gives us 1 minus 3. So, 1 minus 3 is minus 2. Similarly, at this point the signal coming here is 2 and from this branch the signal coming is 4. 2 minus 4 is minus 2. Okay. We got the output of first stage. Now, let us try to write the input to second stage. So, 4 directly comes here, 6 directly comes here, minus 2 multiplied with minus 1 gives you minus 2, minus 2 multiplied with minus j gives us j2 plus j2. Okay. Now, we are ready with the input of second stage. Let us try to find out the output of second stage. So, at this particular point, these two branches are meeting. The signal coming from this branch is 4 and the signal coming from this branch is 6. 4 plus 6 is 10. Okay. Similarly, at this point the signal coming here is 4. So, from this branch 6 is multiplied with minus 1 gives us minus 6. So, what is the resultant of this particular, at this particular node it is 4 minus 6 which gives us minus 2. Okay. Now, let me stand at this point. Here the signal coming is minus 2 and from this branch the signal coming is plus j2. At this particular point the signal coming is minus 2 and j2 is multiplied with minus 1 which gives us minus j2. So, multiplying minus 2 with omega 4 power 0, we know omega 4 power 0 is nothing but equal to 1. So, minus 2 into 1 is minus 2. Similarly, multiplying minus 2 minus j2 with omega 4 power 0, that also gives us minus 2 minus j2. Therefore, x of 0 is 10, x of 2 is minus 2, x of 1 is minus 2 plus j2, x of 3 is minus 2 minus j2. So, we found out the DFT. Now, let me tabulate those things. So, therefore, x of k is equal to, what is x of 0? It is 10. X of 1 is minus 2 plus j2. X of 2 is minus 2. X of 3 is minus 2 minus j2. So this is how we can use DIFFT algorithm to compute DFT for 4 points. Okay. So in the next problem, let us see how to compute DFT using DIFFT algorithm for 8-point DFT. So the next problem is compute 8-point DFT of the sequence x of n, which is equal to 4 ones followed by 4 zeros using DIFFT algorithm. So this is the complete structure for DIFFT algorithm when the value of n is equal to 8. So if n is equal to 8, I can express 8 as 2 power 3, where the value of v is equal to 3, which tells that it should have 3 stages. So this is the first stage, this is the second stage, and this is the third stage. Okay. Now first let me tabulate the value. So x of 0 is 1, x of 1 is 1, x of 2 is 1, x of 3 is also 1. Rest of the values are equal to 0. So from the sequence I have tabulated the input for stage 1. Okay. Now standing at this point, so the signal coming from this branch is 1, the signal coming from this branch is 0, 1 plus 0 is 1. Similarly, here the signal coming is 1, and from this point the signal coming is 0, so 1 plus 0 is equal to 1. Similarly, at this point the signal coming here is 1, and from this branch it is 0, 1 plus 0 is 1. At this point the signal coming here is 1, and from this it is 0, so 1 plus 0 is 1. Coming to the next part, so from this branch the signal is 1, from this branch it is minus 0, so which gives us 1 only. At this point the signal coming here is 1, and here it is 0, again it is 1. Coming to this point, so signal coming here is 1, 1 minus 0 is 1, so here also it is 1 minus 0, which is equal to 1. So we got the output of first stage. Now let us write the input to second stage. So if I write the input to second stage, so it is 1, 1, 1, 1, 1. Multiplying these two gives us the same value. So it is nothing but 0.707 minus j 0.707. Again multiplying 1 with minus j gives us minus j. And again this multiplied with 1 gives us minus 0.707 minus j 0.707. Okay. So we are ready with input of the second stage. Let me try to find out the output. So at this particular point, from this branch the input is 1, from this branch also the input is 1, 1 plus 1 gives us 2. So at this point, so the input coming here is 1, here also it is 1, so 1 plus 1 is 2. Okay. So now standing at this particular point, here the data coming is 1. So in this branch 1 is multiplied with minus 1, so 1 minus 1 is 0. Similarly at this point the data coming is 1, 1 is multiplied with minus 1, 1 minus 1 is 0. Okay. At this particular point the data coming is 1, and from this branch it is minus j. Clear? So again at this particular point the data coming from this branch is 0.707 minus j 0.707, whereas from this point it is minus 0.707 minus j 0.707. So the real terms gets cancelled and we are left out with imaginary term, which is equal to, so 7 plus 7 is 14, so 4, 1, again 7 plus 7 is 14. It is nothing but equal to minus j 1.414. Okay. So again coming to this point, the signal coming from this branch is 1. So minus j multiplied with minus 1 gives us plus j. So it becomes 1 plus j. Again at this point, so this is the signal coming at this point, and at this particular data is multiplied with minus 1, which gives us 0.707 plus j 0.707. So at this particular point what happens, the imaginary terms gets cancelled, we are left out only with real value. So the value is 1.414. Hope it is clear. So we got the output of second stage. Now let us write the input to first stage. So 2 comes directly here. So this 2 comes here, 0 multiplied by anything is 0. So 1 minus j comes here, minus j 1.414 comes here. 1 plus j multiplied with 1 gives us 1 plus j. So, multiplying this with minus j gives us minus j 1.414. Okay. Now, let me try to find out the output. At this point, the signal coming is 2 and 2, 2 plus 2 is 4. Here the signal coming is 2, 2 into minus 1 is minus 2, 2 minus 2 is 0. So, at this 2 stages the output will be 0 because the input data is only 0. Again at this point, so here the signal coming is 1 minus j and here the signal coming as minus j 1.414 and the result will be 1 minus j 2.414. Clear? Then at this particular point, so since you don't have real term, I will write it directly. So this is getting multiplied with minus 1 which gives us plus j 1.414. So subtracting these two gives us plus j 0.414. Okay. Again at this point, so the signal is 1 plus j minus j 1.414. This gives us 1 minus j 0.414. So coming to this point, this is getting multiplied with minus 1, minus j 1.414 into minus 1 is plus j 1.414. So at this particular point, the output will be 1 plus j 2.414. So did we find out the DFT? Yes. So if you multiply 0 with 1 gives you 0, multiply 0 with 1 gives you 0, multiply this term with omega 8 power 0 gives you the same value. Multiplying this term with omega 8 power 0 gives us the same value. Why? Because omega 8 power 0 is nothing but equal to 1. So in whichever problem you do, one thing what you need to do is you need to show this calculation, that is how you are getting these values for omega 8 power 0, omega 8 power 1, omega 8 square and omega 8 cube. Here I am writing it directly. Okay. So finally we found out the DFT. The output is in bit reversed order. So let me write the output in an order. Therefore, x of k will be equal to, what is x of 0? X of 0 is 4. X of 1 is 1 minus j 2.414. X of 2 is 0. X of 3 is 1 minus j 0.414. X of 4 is 0. X of 5 is 1 plus j 0.414. Similarly, so we are done with x of 5, then it should be x of 6. X of 6 is 0. X of 7 is 1 plus j 2.414. So this is how we can compute 8-point DFT with the help of DIFFT algorithm. Moving on to the second problem. So this problem has two parts, that is two questions. So the first question is compute 8-point DFT of the sequence x1 of n which is equal to 1 2 minus 1 2 4 2 minus 1 2 using DIFFT algorithm. And the second question is, given x2 of n is equal to x1 of minus n of n, compute x2 of k without using FFT. So what they have done is, they are giving us the relationship between x2 of n and x of n. With the help of this relation, try to find out x2 of k, but we should not use any kind of FFT algorithms. Okay. So first let us try to find out x1 of k, then let us move on to the second question. Okay. The first question is to find out x1 of k for the given sequence. So this becomes x1 of 0, x1 of 1, x1 of 2, x1 of 3, x1 of 4, x1 of 5, x1 of 6 and x1 of 7. So tabulating all the data, so x1 of 0 is 1, x1 of 1 is 2, x1 of 2 is minus 1, x1 of 3 is 2, x1 of 4 is 4, x1 of 5 is 2, x1 of 6 is minus 1, x1 of 7 is 2. Okay. Now at this particular point the data coming is 1 and from this branch it is 4, 1 plus 4 is 5. Again at this particular point the data is 2 and here also the data is 2, 2 plus 2 is 4. From this branch the data which we are getting is minus 1 and from this branch also the data which we are getting is minus 1, minus 1, minus 1 gives us minus 2. Now coming to this point, here the data is 2. So here the data, this particular point it is 2 and this data is also 2. 2 plus 2 gives us 4. Clear? So coming to this point, the data coming here is 1. 4 is multiplied with minus 1 gives us minus 4. 1 minus 4 is minus 3. At this point, the input from this branch is 2. The input from this branch is minus 2. 2 minus 2 is 0. Again at this particular branch, the data coming is minus 1. So minus 1 is multiplied with minus 1 gives us plus 1. Minus 1 plus 1 tends to 0. Again at this point, here the input is 2 and from this branch we are getting it as minus 2. 2 minus 2 is 0. So we got the output of first stage. Okay. Since it was 8-point DFT, I have written 8-point DFT butterfly structure. Why? We get 3 stages. We know n is equal to 8, which can be expressed as 2 cube. So the value of V is 3, which tells 3 stages. So I have taken 3 stages structure. So now let me write the input to this second stage. So 5 directly comes here, 4 comes here, minus 2 and 4. Minus 3 multiplied with 1 gives us minus 3. Rest of the terms which we have is 0. Multiplying 0 with any of the terms gives us 0 only. Okay. Now coming to the output of second stage, this branch is giving us 5 and from this branch it is minus 2. 5 minus 2 is 3. At this point, the data coming from this branch is 4. The data coming from this branch is also 4. 4 plus 4 is 8. Again here, the data coming here is 5. Minus 2 minus 1 is plus 2. 5 plus 2 is 7. At this point, you are getting 4. This is multiplied with minus 1. 4 minus 4 is 0. Okay. So standing at this point, the data coming from this one is minus 3. From here it is 0. Minus 3 plus 0 is minus 3. Here we get 0 because the input from both the branches are 0. Again here, the data is minus 3, minus 0 gives us minus 3. Again at this point, it is 0. So we got the output of second stage. So now let us try to write the input to third stage. So 3 comes here, 8 comes here, 7 multiplied with 1 gives us 7. 0 with minus j gives us 0. 3 directly comes here, 0. Minus 3 into 1 is minus 3. 0 multiplied with minus j is 0. So now we are ready with the input to third stage. Let me try to find out the output of third stage. So at this particular point, it is 3 plus 8, which is 11. At this point, it is 3 minus 8, which gives us minus 5. So this is 11. So at this point, it is 7. Again here, the inputs are 7 and 0, which gives us 7. Here it is minus 3 and 0 gives us minus 3. At this point also it is minus 3. Again here minus 3 and 0 gives us minus 3. Here also we get minus 3. Multiplying minus 5 with omega 8 power 0 gives us minus 5. 7 with omega 8 power 0 gives us 7. Minus 3 multiplied with omega 8 power 0 gives us minus 3. Similarly, this minus 3 multiplied with omega 8 power 0 is minus 3. What we did? We got x of k. So, let us tabulate that. Okay. Therefore, x of k is equal to, what is x of 0? X of 0 is 11. X of 1 is minus 3. X of 2 is 7. X of 3 is minus 3. X of 4 is minus 5. X of 5 is minus 3. X of 6 is 7. X of 7 is minus 3. So, did we find out the 8-point DFT for the given sequence x1 of n? Yes, so this is x1 of k. Why x1 of k? Because that is x1 of n sequence. So, all this becomes x1 of 0, x1 of 4, x1 of 2, x1 of 6, x1 of 1, x1 of 5, x1 of 3 and x1 of 7. The same values I have tabulated here, which gives us x1 of k. So, this is the solution for the first question, that is to compute 8-point DFT for the given sequence using DIFFT algorithm. Now, the second question is to compute x of k. So, let us see how to compute x of k with the help of this x1 of k. what I did in the beginning, we completed the first question, that is we found out 8 point DFT. The second question is given x2 of n is equal to x1 of minus n of n, compute x2 of k without using FFT. So for that what I have done is I have written x1 of k which we computed from which we got from first question, that is question number A. Now what is the given data? So they have given x2 of n is equal to x1 of minus n of n. Okay, we know that. So if I apply DFT to x2 of n, I can write it as x2 of k, correct? From time reversal property, what we know? Time reversal property, or we call it as reflection property, we know DFT of x1 of minus n of n is nothing but equal to x1 of minus k of n. So which we have already proved and which we have studied. Now what I need to do, if I apply DFT to this particular equation, so let me term this as equation 1. Applying DFT to this, x2 of n can be replaced with x2 of k, x1 of minus n of n can be replaced with x1 of minus k of n. So let me write, that is apply DFT to the first equation gives us x2 of k which is equal to x1 of minus k of n. So this can also be written as x1 of n minus k. Okay. Now from the given relationship we deduce this. In order to find out x2 of k, the question is to find out this one. I got the relationship of x2 of k with respect to x1 of k. I know what is x1 of k. With the help of this equation, let us try to find out what is x2 of k. Okay. So first, let the value of k be equal to 0. Okay. We all know k ranges from 0 to n minus 1. So the first value is 0. I have taken it as 0. So this is our x1 of 0. This is x1 of 1. So this is x1 of 2. This is x1 of 3. x1 of 4. x1 of 5. x1 of 6. This is x1 of 7. Okay. So when k is equal to 0 in this equation, we get what is x2 of 0, which is nothing but equal to x1 of, it is n minus k. What is the value of n? It is 8 point. So n is 8 minus k is 0, which is nothing but equal to x1 of 8. So x1 of 8 is nothing but it is same as x1 of 0. Yes. So what is the value of x1 of 0? It is nothing but equal to 11. So this is equal to 11. So what we did, we found out what is x2 of 0. Similarly, let k be equal to 1. So if k is equal to 1, x2 of 1 will be equal to x1 of 8 minus 1, which is equal to x1 of 7. So what is the value of x1 of 7? x1 of 7 is nothing but equal to minus 3. Therefore, what is the conclusion? x2 of 1 is equal to minus 3. Let k be equal to 2. If k is equal to 2, x2 of 2 will be equal to x1 of 8 minus 2, which is equal to x1 of 6. Okay. So what is x1 of 6? x1 of 6 is nothing but equal to 7. Yes. So therefore, x2 of 2 which is equal to x1 of 6, that is equal to 7. Now the next value of k be equal to 3. If k is equal to 3, x2 of 3 will be equal to x1 of 8 minus 3, which is equal to x1 of 5. So what we are doing here, the value of x1 of 5 is equal to x2 of 3. What is x1 of 5? x1 of 5 is nothing but equal to minus 3. Therefore, x1 of 5 is equal to minus 3. Now, let us give the next value of k which is equal to 4. So if k is equal to 4, x2 of 4 will be equal to x1 of 8 minus 4, which gives us x1 of 4. So, the value of x1 of 4 is same as x2 of 4. What is x1 of 4? x1 of 4 is nothing but equal to minus 5. So, this is equal to minus 5. So, what should be the next value of k? Let k be equal to 5. If k is equal to 5, x2 of 5 will be equal to x1 of 8 minus 5, which is equal to x1 of 3. What it is telling? The value of x1 of 3 and x2 of 5 are same. What is the value of x1 of 3? x1 of 3 is nothing but equal to minus 3. So, x2 of 5 is also equal to minus 3. So, the next value of k is, let k be equal to 6, x2 of 6 be equal to x1 of 8 minus 6, which is equal to x1 of 2. So, the values of x2 of 6 and x1 of 2 are same. The value of x1 of 2 is 7. Therefore, the value of x2 of 6 is also equal to 7. So, what is the next value of k? The last value of k. Let k be equal to 7. So, if k is equal to 7, so what is x2 of 7 equal to? It is nothing but equal to x1 of 8 minus 7, which is equal to x1 of 1. Okay. So, what we got? So, the value of x2 of 7 is same as x1 of 1. So, what is x1 of 1? x1 of 1 is nothing but equal to minus 3. So, we got it as minus 3. Okay. What was the question? The question was to compute x2 of k with the help of this given relationship without using FFT algorithm. So, did we use FFT algorithm? No, we used the properties of DFT and we deduce what is x2 of k. So, like this we can solve problems if they give any relationship and if they tell you to find out the DFT. Okay. So, now at last let me tabulate the values of x2 of k. Therefore, the value of x2 of k is equal to, what is x of 0? X of 0 is 11, x of 1 is minus 3, x of 2 is 7, x of 3 is minus 3, x2 of 4 is minus 5, x2 of 5 is minus 3, x2 of 6 is 7, x2 of 7 is minus 3. So, this is how we can compute the DFT with the help of property by first finding out x1 of k, which gives the answer for first part of the question. For the second part of the question, what we do? We take this solution, we try to apply DFT to this equation. So, we know if we apply DFT to x1, x2 of n, it gives us x2 of k. Similarly, by time reversal property, if x1 of minus n of n, DFT is nothing but equal to x1 of minus k of n. Just by these two things, if I apply DFT to this, x2 of n can be written as x2 of k and this can be written as x1 of minus k of n, which can also be written as x1 of n minus k. Then by substituting the values of k, we know the value of capital N is 8 because it is 8 point. Okay. And we know k ranges from 0 to n minus 1. So, n value is 8, 8 minus 1 is 7. So, the range of k is from 0 to 7. So, if we give the values of k from 0 to 7, we get the values for x2 of k, finally tabulating that it completes the solution for second question. So, this is how we can find out the DFT for the given relationship. So, in today's class what we saw how to find out the DFT for 4 point as well as 8 point, and this is one of the different problem with respect to relationship with the help of DIFFT algorithm. So, in next class let us see how to find out IDFT. Thank you.